topic for this week is about geometric means. So to define again what is a geometric mean, let us use this example, a geometric sequence. In this given example, 2, 4, and 8 are what we call the geometric means because they are in between the first and the last terms given, while 1 and 16 are what we call the extremes. The first term and the last term are what we call the extremes. The terms in between the extremes are what we call the geometric mean. Okay. In solving for geometric means, we have the formula m equals positive negative square root of a times b, where m is what we use to denote the geometric mean, while a is the first given term in a sequence and b is the last given term in the geometric sequence. Let's have an example. Example number 1. Insert one geometric mean between 2 and 18. The first step in solving for this example number 1, insert one geometric mean between 2 and 18 is write the sequence in this form, 2 blank 18. This blank represents the geometric mean that we are looking for because we are only looking for one geometric mean. That's why we have one blank in between 2 and 18, the given terms. Next, evaluate using the formula m equals positive negative the square root of a times b. Now, in using this formula, you will only use this if you are looking for only one geometric mean. A represents, again, the first term 2, and b represents the last term 18. So in the given, we have 2 as a and 18 as b. So we will just use this formula. So let's proceed. We have m equals positive or negative, that is from the formula square root of a times b. So we have 2 times 18. So just simplify. What is 2 times 18? So 2 times 18 is equal to 36. And what is the square root of 36? So we have positive and negative 6, meaning our geometric mean is positive 6, negative 6. Last step, complete the sequence and check if there is a common ratio. So there are two possible answers. It is either positive 6 or negative 6. But we need to check if which is correct or are both the numbers correct. So how do we check that? By finding if there is a common ratio. Let us use first the positive 6. So if we have 2, and let's say the geometric mean is 6, we have 6 and 18. So we need to check if there is a common ratio in this sequence. So finding the common ratio, we have 6 divided by 2, that is 3, and then another one, we have 18 divided by 6, which is also 3. So there is a common ratio if we are going to use positive 6 as a geometric mean. So meaning 6 is correct. But we also need to check if negative 6 will give us a common ratio. So let's start with negative 6. So 2, we have negative 6 as geometric mean, and 18. Let us check if there is a common ratio. So negative 6 divided by 2, that would be negative 3. While the other one, we have 18 divided by negative 6, will also give us negative 3. So you see, it also has a common ratio, which is negative 3. Therefore, the geometric means that we can use is either positive 6 or negative 6. there are two possible answers. Example number 2. Insert 3 geometric means between -2 and -162. First step, just like our first example, write the sequence -2, 3 blanks, blank, 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 and -162. Again, these 3 blanks represent the 3 geometric means that the problem is asking for. Second step, use the ratio formula to solve for the common ratio. We have R equals n minus k roots of a sub n divided by a sub k. And we have a new formula, which is R equals the root n minus k of a sub n divided by a sub k, where our a sub n is the last term, which is, from this example, it's -162, and then our a sub k is our first term, which is -2. Since our first term is -2, therefore the value of k is now 1, since that is the first term, while n is the nth term, -162. So how many terms are there? So if this is a sub 1, we are looking for a sub 2, a sub 3, and a sub 4. Therefore, 162 is a sub 5. So therefore, n equals 5. So what we will do is just simply substitute all this given to the ratio formula, to our new ratio formula. So we have R equals our n, that is 5. So 5 minus k, which is 1, square root, or the root of a sub n. Our a sub n again is our last term, which is -162, and the first term a sub k, which is -2. So we'll simplify this. We have 5 minus 1 is 4. Root of -162 divided by -2, positive 81. So solving for our common ratio, we have simplified the fourth root of 81. R equals 3. So this is now our common ratio. The last step, multiply each term by the common ratio. So we'll start with -2. To find the next term, which is a sub 2, we will multiply our first term by the common ratio. So a sub 2 equals -2 multiplied by the common ratio, which is 3. So that is equal to -6. Therefore, our a sub 2 is -6. Next, a sub 3. So for a sub 3, multiply our a sub 2 by the common ratio. So I have -6 multiplied by 3, that would be -18. So we have -18 right here. And lastly, for our a sub 4, a sub 3 multiplied by our ratio, which is 3, is -18 multiplied by 3 equals -54. So we have a -54 right here, completing our sequence with geometric means -6, -18, and -54. We are now in the last topic for the week, finding the formula for the nth term of a geometric sequence. So let's start with an example. A geometric sequence 1, 2, 4, 8, and so on. So what are we going to do? We'll find a formula for a specific geometric sequence. Let's start with our first step. Match each term with its corresponding term number. So following our table, since we have 4 given terms. We have the first, the second, the third, and the fourth term. So what is under the first term? Of course, we have 1, since 1 is our first term. Under the second term, we have 2 from the given. We have 4 as our third term. And we have 8 as our fourth term. Step 2. Determine the common ratio. So in finding the common ratio, of course, we will start with our formula. A term divided by. So let's start with our second term divided by the first term. 2 divided by 1 equals 2. Third term divided by second term. 4 divided by 2, still 2. And then the fourth term divided by the third term, we have 8 divided by 4, which is also 2. So, therefore, our common ratio is 2. Step 3. Using the general formula for geometric sequence, substitute the value of a sub 1 and the common ratio. So, this is the general formula of a geometric sequence. A sub n equals a sub 1 multiplied by r raised to n minus 1. And from the given, we have 1 as our first term, so that is our a sub 1. And from step 2, we got the common ratio, which is 2. So let us substitute. So we have a sub n equals 1, that is from the first term, multiplied by 2, which is our common ratio, raised to n minus 1. And any number multiplied to 1 is always equal to the number. So simplifying this equation, we have 2n2 raised to n minus 1. So this formula is now the formula in finding the nth term of this given sequence, 1, 2, 4, 8, and so on. So let's say we want to find the 100th term of this given sequence. So you will just use this formula to easily find the 100th term. Okay, but of course, before concluding our solution, we need to check if this is really the formula for this specific geometric sequence. So let's have the checking. So in checking, check each term to be the same as the given sequence. So this is our formula from step 3. If n is 1, if we're going to substitute the value of n, which is 1, to the formula a sub n equals 2 raised to n minus 1, are we going to get the value of the first term from the given example, which is 1? Let's see. So substituting, we have a sub 1, since n is 1, equals 2 from the formula raised to 1 minus 1. We replace n by 1 since we are checking if we will get the first term. So what is 1 minus 1? That is 0. And from the law of exponents, any number raised to 0 is always equal to 1. So see, the value that we got for a sub 1 is the same as the value of the first term in the given sequence. Let us check if n equals 2. So a sub 2 equals 2 raised to 2 minus 1. 2 minus 1, which is equal to 1, and any number raised to 1 is always equal to the number. So that's 2. A sub 2 equals 2, which is also the same as the second term of our given sequence. What if n is equal to 3? So a sub 3 equals 2 raised to 3 minus 1, and 3 minus 1 is equal to 2. 2 squared is equal to 4. So a sub 3 is 4, which is also correct. Lastly, what if n equals 4? Substituting, a sub 4 equals 2 raised to 4 minus 1. 4 minus 1 is equal to 3, and 2 cubed is equal to 8, which is also our fourth term. Therefore, we can conclude that this formula is the formula in finding an nth term if the sequence goes 1, 2, 4, 8, and so on.